Welcome back my dear friends and dear students. A very good morning, good afternoon, good evening to all of you wherever you are. I am considering that some of you may be outside India and taking this course. So, that is why it can be at any point of time. Now, this is the DADM 2, which is Data Analysis and Decision Making 2 lecture under the NPTEL MOOC, and as you know that this total course is duration was for 12 weeks, which is 60 lectures and which gets converted into 30 hours of lecture. 30 hours because each lecture is basically for half an hour, and we have already completed 11 weeks. So, you have already, and each week with 5 lectures, and you have already completed 11 assignments. We are in the 12th week, and as you can see we are in the 57th lecture. So, with the end of this set of lectures till 60, you will complete the you will definitely complete the assignment till 12, and then we ready to take the question paper, the final examination. And my good name is Raghunandan Sengupta from the IME department, IIT Kanpur in India. So, if you remember, we are considering the sickness prediction, considering the good and bad companies, and in the last class we discussed that how we can compare whether the prediction or the models themselves are good enough, and we used 2 different tests, rank tests and all and such tests to compare how good or bad the pairwise comparison of the results were, and they came out to be very good for the set of companies which we took for 2002, 2003 and 2004. Now, we basically set some parameters for, now we are going to actually come to our AI's application. Now, the AI's application will use the algorithm which you are not developed based on the AI's concept. We have basically made it fine tuned for our this application in financial prediction. So, the algorithm is negative along with the clonal, both clubbed together, positive, and along with clonal they will be utilized. So, obviously, if you remember for the clonal one we had the thresholds R1, R2, R3, then based on that we picked up from that capital NS non-self one, we picked up small n1, small n2, small n3. So, we have to basically decide that. So, based on that we have the procedures being the final setting of the combined data set, and this combined data set can be of one set which matches, another set which does not match. We basically utilize that for both the sets. The parameters are, we take in the final procedure 3, which is the combined one, we take through threshold. This threshold need not be only 2, it can be more than that. We take 2 thresholds R1 and R2, and the numbers are basically N1 and N2, which is basically these are the parameters set for the combined data analysis, and the final parameters based on which for the comparison for the statistical models utilized based on how we replicate again is given as n, then we will take R1 and R2, and based on that we proceed. Now, remember one thing, you may be thinking that here it is 300 while the values are 10 and 250, here the value is 900 while the values are basically 30 and 750, which is not matching addition. Yes, it may be possible, because if you take the threshold to N3 R3 level, obviously some those threshold would be there. So, we are keeping some level of bound for the threshold such that there may be some elements or sets or individuals, I am considering the individuals as the companies which may not match. So, obviously, those concept of threshold would not be applicable to them. It is basically we have a sieve and we are basically straining them. So, there may be some particles which basically go through both the levels of strainer. So, the strains and sieves RC for example of a value of R1 and R2, and R1 and R2 are such that there may be some particles which go through that, we are not going to consider that, and N1 and N2 are the number of particles which remain in the sieve accordingly. Now, once we compare, so the comparison part I have already told, again I repeat, and why, and if you remember I said that we will do it comparison between both positive clonal, negative clonal. So, again I will repeat, a company is taken with all the ratios, all the values on the financial front, and we, if we use the negative, and we have already those 2002, 3, 4 good and bad sets, non bankrupt, bankrupt, good and bad. So, when we basically compare them using the negative or the positive, a new company comes based on the ratios, the thresholds, whatever decided, we can change the thresholds. We are too strict or too laxed would basically dictate the value of the threshold. In the negative one, if they do not match, so it is kept aside, which means it is a good company, and in the negative one, if they match, it is kept aside on the other side, which is a bad company. Now, this was the negative and negative clonal. Now, whether the companies have been grouped properly, we will again run it for the positive one. So, the company which was set aside as a good company should now fall into the good set if you are using the positive selection criteria, and the company which was negative, which was bad under the negative one would now basically be the complementary part. That means, it is no one would be rejected by the good, the positive selection algorithm. Now, this if it matches, obviously it will mean that there is no error in both these cases, but there would be errors obviously, as we can see from, we will see from a diagram. So, the general hypothesis as applicable from the problems are H naught is that all the companies directed by the director set are bankrupt, and H 1 is the number of companies directed by the director set are no companies directed by the director set are bankrupt. So, we will use to utilize this H naught and H A accordingly. H A means H 1. Now, what are the errors? Errors would be a good company is analyzed as bad and a bad company is analyzed as good. So, it can be both the ways in both the algorithms. So, let me draw a diagram in order to clear this concept, and let me it's like this. So, this would go, now let me, I have to basically draw it. So, the space should be there. Great. So, let me create the slide properly, so I can draw it easily and all of you can check. Why it is not moving? Yes. So, it is done. Let me make the diagram. Okay. Now, let us consider. So, I will first draw the, I will give the background. So, consider I will give first the example which I have already done in DADM 1, and then cite a second example which is applicable here, and both are from the financial sectors. So, it will be easy for you to understand. Very simple examples. Consider you are a bank manager and you are chief manager of a bank in a big city or in a big rural district or rural town, and many loan applications come. So, you have to basically take a decision whether you want to give take a decision to give the loan, sanction the loan or deny the decision. Now, when you do that, what you will do consider is that you will consider many of the parameters, that means what is the age of the person, what a business or company where he is working, whether he has a business, whether he has his own house, or apartment or land, then whether he is paying, obviously they are paying an income tax, but they will consider that what is his income based on and what is the tax he or she is paying, whether he or she has his own vehicle, then whether the person has taken previous loans, and what is what type of sector the person is. So, all these things are what is the age, and all these things, some objective, some subjective criteria are considered. Based on that, you basically set a score as 60. 60 score above, you give the loan, 60 and any score below 60 you deny the loan. So, now graph would be like this. So, these are the score line. So, they would be, and we consider the, so there are many people who are applying for the loan. So, the people who are in the long run would definitely pay the loan. I will draw their distribution as normal and with the color blue. So, these are the people who will pay you back the loan. So, this is the average score. Second set of people who would, who even if you give the loan, they would not return the loan. Average is, and the red color is red. So, obviously, the score is less. Now, consider that you have set for yourself a score of 60, which I mentioned. This is 60. So, this is the score. So, I am writing is as 60, and consider this score is, say for example 75. Don't, I am not drawn to scale. Consider this is 55, not 55, it is, it should be now. Consider the problem. I will use a different color to highlight it. Now, consider this area, and this area let me mark as yellow with the highlighter. So, this portion. So, this yellow portion is for those set of people who, if given a loan, would not return, and this set of people who, even if they are good, they are denied the loan. So, they are denied the loan. So, obviously, these would be two errors. So, the errors I will mention as alpha. This should not be such board. Alpha and beta, these are the errors. Now, you will think that what if I decrease or increase 60. So, I take the line 60 onto the right or the left, but the issue is that if I take onto the right, the blue portion increases, the yellow portion decreases. Similarly, you take 60 on the left, the blue portion decreases and the yellow portion increases. In both the ways, it is a loss for you, for the bank manager. Why? Yellow means bad debt, they would never be returned. Blue means opportunity cost, opportunity loss for you, business. So, both these are good customers gone, bad customers come in. Now, trying to basically minimize a sum of alpha beta is the best way, and we have methods how to tackle it in statistics, hypothesis testing. Consider the same example. Now, as I said, I will consider the example as applicable for the banks. So, banks consider the same type of distribution normal, good companies, bad companies, you set a score threshold for yourself. Threshold means that the values which you have taken R1, R2, N1, N2. So, obviously, you can make it more refined, but obviously, you would not like to spend so much of time in trying to do the refinement. You want to double check how good or bad your results are. And if you remember the comparison which you did between two models taken two at a time, and based on that you basically, in one case you do not want to reject H naught, and in one case you want to reject H naught, and both the results in both the tests, rank test and all these things, selection tests were coming fantastic. So, in this case you will basically consider the companies which are bad, they have been predicted as bad in both the models, negative selection, positive selection, and the companies which are good have been analyzed accordingly, negative selection and positive selection. So, negative bad companies, bankrupt companies prediction means under the negative selection algorithm would be, if they are bad they would be clubbed as bad, and when you take the positive selection they would not be clubbed in the good set, they would be kept aside, and vice versa would be done for the case of the good companies. If they are utilized in the negative selection algorithm, they would be not clubbed as bankrupt, they will be kept aside, and when you are using the positive selection algorithm, they would be clubbed and kept in the set which are good companies. So, based on that, if both of them match, obviously the error is minimum. Now, we do an R1 R2 combination based on which we found out. So, R and R2 combinations would be done in such a way. So, in the negative selection algorithm, if you remember, we are taking the sum of alpha plus beta. So, we are changing the ratios, and if we consider the positive selection and negative selection algorithm for a combination, so 45 30. So, these are the combinations I am taking for R1 R2, 47 25, 45 30, 45 20. So, there can be different combinations. I am starting from 47 30 to 45 25. It can be others also, I can start in. So, obviously, the groups would be 47 and then 30 25, 30 25, 30 25 or 30 40, so on and so forth. I am just taking arbitrarily few sets depending on the problem. So, I find out under the negative selection and the positive selection comparison the sum of alpha beta, the errors. So, the errors in the percentage sense would be 40%, 25%, 25%, 7%, 62, 3, 72, 24, 11, 6. So, if you consider a combination of values gives me a value of errors of 32 and 17. So, any combination better than that obviously would be great. So, I do it for 2002. Similarly, I do it for 2003. So, the combinations are, this is the best one 19, other values are quite high. Similarly, I do it for 2004, values are 9, this value is also decent enough. So, obviously, there would be an error. So, there are errors because you can definitely fine tune the model depending on your R1 R2 combinations and the collection of sickness. So, it may be possible some of the companies we are taking as sick or good companies may not actually be that. So, obviously, in the data set based on which you are trying to proceed, there might be errors. So, we take the errors for type 1 and type 2 percentage wise. So, under procedure 1 and procedure 2, the comparison we do, the averages of the type 1 type 2 errors are coming out to be about 2%, and type 2 errors is about 1.5 and 1 is 0.9 I am considering as 1, and the standard errors would also give you the amount of dispersion which you have. So, these are the classified results for 30, 47 and 30, the comparison which we got the best results. Now, why you are saying that, why do you get an average and the standard data? With those values on R1 and R2, I repeat the algorithm. So, it is basically a random generation number. So, clones are being generated randomly or the mutations are happening randomly. So, based on that it gives me the average values. So, I get decent results based on the values. So, to conclude, the AIS conclusions or the artificial immune system conclusions are, performance of the hybrid models are better than that of the standard model. So, one can utilize a hybrid one. I am not given the detailed results, it is basically it would be a combination of clonal one, before that we do the negative and the positive one at a time, or you use the positive and the negative one at a time. So, we go first negative, you select the companies as bad. So, they are grouped in the S set and others are kept in the complementary set of S which are good. Then again we pass the same things, under the positive selection one. So, the set which is in complementary one, they would be put in now the T set. T is the good set of good ones which we keep, and initially S and S dash, T and T dash would be empty. So, similarly, the S which were bad, when they go into the positive selection, they are put in the T dash set. So, if we utilize that, the results are much better. The overall performance on all the 3 AIS models are better than the statistical models, those results which gave. No discriminating coefficients were required. So, the values which based on which we got the results were good. AIS models can be used in any economic activities or other type of problems. They can be applied irrespective of the size of the firms. So, the size of the firm did not matter here, we checked it, and there are subjective and objective criteria also which can be done. No cutoff was used so as to create a bias in predicting as a statistical model which were used. So, with this I will conclude this second lecture for the last week and try to go into the other topics accordingly for the next 3 lectures. Have a nice day and thank you very much.